Hello everyone, I am Suchita Muril. Welcome you all in the video lecture on the topic Properties of Z Transform Part 2. In Part 1, we discussed the definition of Z Transform and some properties of Z Transform, that means linearity property, change of scale property. Now, here we solve problems on change of scale property. Here, find Z transform of a to the power n. Hence, find Z transform of sin alpha n and Z transform of cos alpha n. Now, here Z transform of 1 equal to summation n equal to 0 to infinity. Here we substitute the value f of n, that means 1, z to the power minus n. We get this sequence. If we observe this sequence here, first term is 1 and common difference is 1 by z. Therefore, we write down here 1 upon 1 minus 1 by z. Its value is z upon z minus 1. This is the z transform of unit step function and 1. Therefore, if we write down z inverse of z upon z minus 1, its value is 1 or u of n. Now, for Z transform of a to the power n, we apply this change of scale property. A to the power n into f of n, here a to the power n as it is into 1, that means f of n equal to 1, then f of z is z upon z minus of a. Then Z transform of a to the power n, we write down this in this form, and Z transform of 1 is z upon z minus of 1, and then we replace the z by a, therefore we get this term, and z transform of a to the power n is z upon z minus of a. And if we write down this in terms of z inverse of z upon z minus a is a to the power n. Now, for finding the Z transform of sin alpha n and cos alpha n, we know that e to the power I theta is cos theta plus I sin theta. We write down in terms of e to the power I alpha n. Theta is replaced by alpha n. Therefore, we taking this Z transform on both sides of equation 1. Then we write down equation 2. Here we consider the left hand side of this Z transform of e to the power I alpha n. Here we consider write down this value as a to the power n. Therefore, z upon z minus of a is e to the power I alpha here. Multiply and divide by z minus e to the power minus I alpha, and then separate the terms. Open the bracket, multiply the terms, combine the terms. Now here z square, substitute the value of e to the power minus I alpha is cos alpha minus I sin alpha, and here combine the terms of z, and here last of its value is 1. Therefore, we write down this as z square minus z cos alpha and separate the imaginary part. Here denominator term is z square minus, here we add z, multiply and divide by 2, its value is cos alpha. Therefore, 2 cos alpha z plus 1. Now separate real part and separate imaginary part. On equating real and imaginary part, here left hand side of the equation 2 is z transform of cos alpha n plus I sin z transform of sin alpha n. On equating real part, we get the value of z transform of cos alpha n, and equating the imaginary part of this equation, then we get z transform of sin alpha n. These two equations we can write in the form of z inverse. We get these values, equation number A and B. Now, here, find the Z transform of C to the power n cos alpha n and Z transform of C to the power n sin alpha n. For this, we apply the change of scale property. That means Z is replaced by Z by A, but here constant value is C, therefore Z is replaced by Z by C. Simplify the terms, we get this is the required result. Now Z transform of C to the power n sin alpha n, Z is replaced by Z by C, and this is the value. And if we write down in the form of Z inverse, this is the formula. Now the shifting property, Z transform of f of n equal to capital F of Z, then Z transform of f of n plus a equal to z to the power plus minus of a f of z. Now here we consider Z transform of f of n plus minus of a. Therefore, instead of f of n here this value we write down this, apply the definition, and next step we adjust here plus minus of a terms. Here negative sign is outside, therefore minus plus, and here plus minus we get adjust the terms. Now here z to the power plus minus of a we taking outside because here summation for n equal to plus minus infinity. Therefore here this value outside and remaining term we write down as it is. Now here n plus minus of k equal to k equal to k. Therefore n plus minus of a equal to k. Therefore, this value f of k and z to the power minus k summation value as it is, and this complete value we write down as capital F of j, and hence this shifting property is true. Multiplication by n property. That means here we have to find out the z transform of n into f of n, its value equal to minus z into d by dz of f of z. Here we consider the left hand side and summation n equal to minus infinity to infinity n f of n z to the power minus n. This is the definition of Z transform. Then we write down, adjust the negative sign as well as Z term. Therefore, here we negative sign here and here this become plus, and Z here z to the power minus of 1 we adjust it here. And now why we are adjusting these terms here, this negative sign and n, we combine this term here, and this value minus n z to the power minus n minus 1, this is the d by dz of this term, and this is the by definition its value capital F of z, hence we prove this minus z d by dz of F of z. Now we discuss problem on this. Find the Z transform of n u of n, or uh, Z transform of n only, n into 1, and Z transform of n square u of n, or Z transform of n square. Now we know that Z transform of u of n is equal to z upon z minus 1, its value f of z. By using the multiplication by n property, here Z transform of n f of n equal to this value. Now we substitute the values minus z d by dz of f of z, that means z upon z minus 1. We substitute here, apply quotient rule, and then we get the required result z upon z minus 1 whole square. Now for second term, again we apply this multiplication by n property, and for this we consider the value of f of z equal to z upon z minus 1 whole square, that means first result. And again apply quotient rule and simplify the terms. We get value is z square plus z upon z minus 1 whole cube. This is the, if we write down in terms of z inverse, then its value equal to n square u of. In this way, we solve the problems. Now, other properties we will discuss in the part 3. Thank you.